Now, today I want to continue my discussion of statistics, and in particular, I want to talk more about the use of statistics when it comes to probability and how you can use statistics to gauge the probability that something will or will not happen, such as what will happen to your lungs if you smoke 20 cigarettes a day, what will happen to your weight if you eat so many grams of sugar or fat per day, and so forth. And this is where the use and misuse of statistics often comes along. I'm going to give you an old example, one that amused me a great deal at the time because I was studying statistics in school at the time and probability. And it got me to thinking that there is a kind of almost paradox here. I'm thinking about Apollo 13. I didn't pay much attention to the moon missions. I did watch Armstrong land on the moon in Apollo 11 in 1969. And didn't bother with Apollo 12 and wasn't particularly bothered with Apollo 13 either until they had that big incident. And at the time, they had no idea what had happened. We learned later that it had to do with the stirring the oxygen tanks, and there was a short in the electrical circuit and an explosion, blah, blah, blah. You know, like we knew that. But at the time, they didn't know anything. And one of the possibilities was that they had been struck by a meteor or some other rock in the space. And people would come on television and say, well, this is an incredibly rare event. The probability is extremely low. And then one of the commentators asked one of the experts, well, what's the chance of it happening again? And there's an interesting question. Because the chance of it happening the first time, let's say the chance of it happening the first time was 1 in a million. The chance of it happening in the rest of the voyage is still 1 in a million. The probability doesn't change. But the probability that they will be struck twice in one voyage is much, much lower. You end up multiplying the probabilities to come up with the probability of it happening twice. So that there's some comfort in the thought that, oh, okay, I've been hit by a meteor once, so it won't happen again. But the probability is exactly the same. That's something that we need to discuss to understand how probability works and how we need to understand statistics, and particularly how we need to understand averages. So let's get going on that. quite a number of things that are called averages in mathematics, and they have different uses and different properties. There are two that I want to talk about first. One is called a mean, and one is called a median, and they have different uses. A mean is calculated by taking all of the values that you have and then dividing by the number of values to get that kind of average. So that if you have 100 people and you take their heights, you add all of their heights together, you get a gigantic figure that you then divide by 100, and that gives you the average height. Now here's the problem. The average height, when you take the mean, is not necessarily halfway. Like, there's a very common joke or sort of amusing thought that if you are, let's say, of average intelligence, or you are speaking to somebody of average intelligence, then a lot of people will say, well, that means that if a person of average intelligence does that, then half the people in your community or your sample are dumber than the average, like that. And of course 100 are smarter. Well, that's not how averages work. And they only work that way if you have what's called a normal distribution, represented on a graph by a bell curve. The mean, that is the average by summing all of the qualities and then dividing by the number, will be exactly in the middle, and half will be lower than the mean and half will be higher than the mean. And there's numerous statistics that fall in that range. IQ, height, weight, and so forth. But not all distributions are normal distributions. Some distributions are skewed. That is, you may have a few at the upper end that are really, really large, or maybe a few at the lower end that are really, really, really small. And they will affect the average if you take the mean. I'll give you a simple example. I haven't done the mathematics on this. I should, in fact. I'm going to stop, in fact, and do the mathematics and then come back. Okay, I'm back. I think I've got it correct. I'm not 100% sure, but the idea will be there. Let's imagine that you have a place where there are 100 houses. And 99 of those houses are valued at $100,000. But one of the houses is valued at $10 million. Now, just if you think about it without using mathematics, you would say that the normal price of a house in that division is $100,000, but there's one outlier. If you are unscrupulous, let's say you are a realtor, and you are going to sell one of those houses, which normally costs $100,000, but you have an out-of-town buyer who doesn't know the area, doesn't know house prices, etc., etc., you could do this kind of mathematics. You could add up all of the houses, which is 99 times 100,000 plus 1, 10 million, divide by 100, and you get 199,000. So you can then go to a prospective buyer and say, the average price of houses in this division is $199,000. But I've got a great deal for you. I've managed to get this house for 180, and they may even go down to 175. Well, that's all completely unscrupulous, because you have taken the mean and it has been skewed by an outlier at the very upper end. If you took a different kind of average called the median, then you couldn't do that. Well, the way you calculate a median is that you sort all of the values in a line. And so in this case, you've got 100. You get to the 50th in the line, and that's your median. So they're exactly half under the median and exactly half over the median. And in the case of 99 houses at 100,000 plus one at 10 million, the median is 100,000. So that is your average. So the median, not the mean. The median is the statistic that tells you what is exactly in the middle. How many are above and below is exactly the same. So if you say that the median intelligence of the average guy is such and so, then you are on surer ground. Now, here is where it gets, to me, both fascinating and annoying. Many, many universities have student evaluations. And the students evaluate their professors on all kinds of scales. But there's usually a question that says something like, according to your experience, this professor is where on this scale concerning teaching ability. And it's a very important metric, because it's the kind of metric that tenure committees, promotion committees, also even committees associated with pay raises concern themselves with. And it's usually a multiple choice. It's usually this professor's teaching ability is on a scale of 1 to 5, with 1 being the lowest, 5 being the highest. So you've got something like, this teacher is 5, excellent. This teacher is 4, very good. This teacher is 3, average. This teacher is 2, below average. And this teacher is 1, very poor. And the students have to check a box or whatever they do to score. Well, I was the head of a department for 20 years, and I was on tenure and promotion committees for 30 years. And so I viewed these evaluations all the time. And the one thing you learn when you do these, when you check through and get your statistics and then array them, is that every single faculty member, including the really terrible ones, all score above average. They're all 3 point something or higher. That students just do not want to place a faculty member below 3. That means that in their thinking about these things, they're not thinking about all of the faculty members they've ever had and arraying all of their faculty members on a bell curve and then placing this one particular faculty member that they are considering for this class in a place on that scale of 1 to 5. They're always going to place the faculty member above average, which means that the entire faculty of a university is above average, which is nonsense. They can't be. Now, how do we deal with that? It's a good question. So I can have a little bit of fun with statistics and probability concerning life expectancy. I just looked up life expectancy in Cambodia, and life expectancy here is 68.9 years. And as it happens, that's exactly how old I am. I'm going to be 69 at the end of this month, so I'm right on that cusp. Now, should I take that life expectancy at face value? Well, of course not, because there are numerous factors. For one thing, I'm not Cambodian, so I don't have the genetics of a Cambodian. I don't eat like a Cambodian. I live like a fairly prosperous Cambodian. So when you take the average, which in this case is the mean, there are all things to consider, like infant mortality. If there's an infant mortality rate that is very high, then the average life expectancy is going to be low, because all of those children that died as infants are going to be counted in the mean. That's where you would prefer to have a median. Now, I was also looking at life expectancy in Cambodia over time, and when you go back into the Pol Pot era, life expectancy suddenly plummets because Pol Pot was murdering the citizens of Cambodia at an alarming rate. Roughly a third of the population died in the Pol Pot era. So you've got to take in external factors like political genocide. You've got to take into account environmental factors. Some of them may be good. I get a lot of vitamin D because of the sunlight, but I might also be prone to skin cancer because of the sunlight, and so forth. That when you start taking averages, they're not going to be very helpful as predictors unless you look at your own individual circumstances. Now, in my case, I take my blood pressure every day. Used to be a little bit high, used to be knocking around 160 over 120 when I lived in China and when I smoked. And I stopped smoking and I started doing more exercises, not artificial exercises like in the gym, but I walk a lot more. I ride a bicycle a lot more. I now ride a bicycle at least 15 kilometers 3 days a week, and I walk at least 6 kilometers the other days. Sometimes I combine the two. So I'm always active. I take good care of my diet. I don't drink alcohol. I rarely eat salt. I don't eat a whole lot of refined sugar, and so forth. So these are factors that I can take into account. And I also use statistics to take them into account. I look at what happens to people who consume too much sugar, or who drink too much, or who smoke too much, etc., etc. I put them all together, and they will influence my, hopefully, my life expectancy, that I'm not going to suddenly croak just before my birthday. But riding a bicycle on the streets of Phnom Penh carries grave risks. If you've ever negotiated the traffic in Phnom Penh on a motorbike, in a bus, in a tuk-tuk, or whatever, you'll know that it is chaotic. But I'm also vigilant, reasonably smart, reasonably careful. Even so, I have been hit by a motorbike twice, sent sprawling. One time I broke my wrist. Second time, nothing bad happened. But you've got to take into consideration all of these factors when you decide how you're going to live your life. Now, you could do like some people do and just say, oh, well, when my time's up, my time's up. I'm not going to worry. I'm just going to live life the way I want to live. I like smoking cigarettes. I like drinking whiskey. I like eating ice cream. I'm just going to keep doing it, and then I will pop off when I do. I'm not really in that frame of mind. I do look at the statistics, and I do consider the possibilities of them doing me good or causing harm. That is, I'm interested in probabilities. And as I said last time, those probabilities get a little bit snarly, because I'm going to do things that I like when the chances of them causing me harm are, let's say, 1%, because that's a pretty small probability. Unless it's flying, because go back to the statistics from the beginning, if there's a 1% chance of a plane crashing, then taking it one time is not a bad risk. But I'm going to be taking 100 flights in the course of, many, many years. And if there's a 1 in 100 chance of crashing, and I take 100 flights, then the overall probability is that I'm going to be on a plane that crashes sometime or other. I mean, you could think about it in the same way as you can think about tossing a coin, although that's a little bit simple. If you toss a coin once, you have a 50-50 chance of it turning up heads or tails. If you toss it twice, you have a much higher chance of it turning up heads once, because there's a 50-50 chance the first time and a 50-50 chance the second time. So overall, it's not a complete certainty. You could toss 2 tails, but tossing 2 tails only happens 1 time in 4. So you have a 75% chance of tossing at least 1 head, because your probabilities are 2 tosses, 2 heads, 2 tosses, 1 head, 1 tail, 2 tosses, 1 tail, 1 head. That's 3, and the last one, 2 tails. So 3 out of 4 chances you will toss a head 1 time. And the more you toss, the greater the possibility becomes that you will toss 1 head. So if you toss 10 times, it's an almost certainty that you will toss one head. Now I'm going to continue this discussion next time, but I'm going to end for the moment with just one thought. That is, that when you look at statistics, particularly, I'll just take Cambodia again. If you look at the statistics of bus travel versus airplane travel, you are much, much, much safer in the air than you are on the ground. Now, I've traveled by bus a lot in Cambodia, and I've never had any problems, because the likelihood of a bus crash is still pretty low, but it's not as low as I might like. I do occasionally worry a little bit, especially on night buses, but I don't worry too much. But when I get into an airplane, even though the chances of that airplane crashing are just extremely remote, I still have that little frisson when we're taking off, or when you get a little bit of turbulence and the seatbelt light comes on, because my cognition of where I am, like in a steel tube in the air, trumps what I know about statistics. And I can, as much as I like, I can say, don't worry about the turbulence, don't worry about the turbulence, don't worry about the turbulence, it's okay, it's okay, it's okay. I'm still worried about it because my cognition is taking into account what I can feel with my senses, and it overcomes my mathematical certainties. And that's just part of the human condition. We are afraid of things that we shouldn't be afraid of statistically, because we have senses and experience that lead us in the other direction. Okay, I'm going to talk more about that next time. For the moment, like and subscribe, and I'll see you for a recipe on Tuesday.